Hello, year 7. Hope you're doing well. I'm back. You're back. It's lesson 3 of physics of speed, and this is velocity and acceleration. I hope you're okay. Let's get started. So, like before, it's 4 parts a lesson. There are 2 sheets of my homework you can print off. If you haven't got them, not a problem. You can work on online paper. So, get yourself organised, get ready, and we'll get going. So, let's start with some brilliant retrieval. Your first slide is on particles. What can you remember? Pause it now. Off you go. Okay, so here are your answers. So again, if you're not sure on any of the answers, pause the video now, make some quick notes, make sure you are ready to move on. So next slide is back to cells. Again, pause the video now, off you go. So how did you get on? Have a look at your answers, look on the screen now. How did you get on? If you are struggling a little bit, make some notes now, do some revision, make a little card if you need to. And the final slide is back to the current topic, all about distance time graphs. So again, pause the video now. What can you remember from the last lesson? Off you go. Okay, so how did you get on? Have a look at the answers on the screen now. Again, if you've all got them brilliant, fantastic. If not, pause the video now and revise them. So today we're going to be looking at velocity and acceleration, and I'm going to start by going through last lesson's questions. There's quite a lot of questions to do, and it's really important we check how you got on. Now, if you're really struggling with this, don't worry about it. Message me, look online, find some help, but here are the answers. So the first sheet, okay, is now on the board there, so you can look at your answers. Again, there's 8 questions, getting gradually harder. Yeah, you could give a mark out of 14 if you like. The second lot of questions were about this graph here. So you had 4 questions to answer, and the answers are now appearing for you. Again, check your answers. How did you get on? And the final lot of questions you had to answer were on this graph. Again, you had 4 questions. So have a look at your answers. How did you get on? And we are now good to move on to something new. So I'm going to change my camera so you can see my sheet, and we now need to just turn my camera. Sorry, guys. So here is the sheet we're working on for new knowledge today, and it's all about acceleration. So I'm going to just focus my camera for you, and we've got a couple of new words introduced first of all. Now, velocity is a word you may have heard before, and actually it is really straightforward. It is just speed with a direction. So the definition of your STB, though, I'll copy that so we've got the same information, is how far an object moves in a given time in a direction. So the only difference between speed and velocity is that velocity has a direction, and that is the key thing here. And why that's important is when you look at acceleration in a minute, you'll see why if we need to learn about that. So acceleration, again, you probably used this word before, you've heard it before, but the definition you need to know is acceleration is how quickly an object's velocity changes. So it's how quickly the velocity changes, how much faster it gets, how much slower it gets, and that is what you need to know. Now you will see in lessons a negative acceleration. Now that is literally when an object slows down. Whenever you see a negative acceleration, is when an object is slowing down. So for example, if you're in your car and your parents apply the brakes, you are negative acceleration, you are slowing down. So the units of acceleration Okay, they're a little bit different, but again, very also similar at the same time. They are meters per second squared. Now, when you come to writing today, when you use the units, we're going to do m/s squared. So whenever you write acceleration, you always use this unit here, meters per second squared. So the final new bit of knowledge for you is the equation for calculating acceleration. Now again, it's a very maths heavy topic. Now acceleration, to calculate it, okay, now we know acceleration now has the units meters per second squared. And to calculate it, what we need to do is we need to know two things. The first thing is the change in velocity. And we know that that is just speed. So the unit is meters per second. And we need to know also how long that change took. So time for that change to happen, and time, as we know, is measured in seconds. That is the equation you need to know. Now, if you're like me, you like a good symbol equation. Luckily, you write acceleration as A. The change in velocity. Now, in science, whenever you see a triangle like that, that means change in, and it's change in velocity divided by time. So there is your 5 new pieces of knowledge you need to know for today's lesson. So what you need to do is you can pause the video now, have a moment on the whiteboard with a person in the household, make sure you know those 5 questions inside out. So off you go. Right, welcome back. So what we need to do today is the most important part of today's lesson is actually being able to use the equation. And like I did before, I'm going to model some with you, okay? And always copy down what I'm doing, and then when I finish talking, you're going to go away and practice on yourself. So the first question is here. So a cyclist accelerates from 0 to 10 meters per second in 5 seconds. What is her acceleration? Now, you should hopefully remember from lesson 1 my 4 top tips. Step 1 is bug. That's bug the question. So again, we're going to do it together now. So I'm going to bug it so I can see I've got this, and I want to find out that. So I'll bug the question. Number 2, the equation. So try and do this from memory, but write the equation. I'm going to use the symbols. So again, acceleration is equal to change in velocity divided by time. Step 3, substitute. So this time you're going to substitute in your values. Now we can see we have been told the time is 5. So straight away I can see that t is 5. So I'm going to put like that. The change in velocity, they go from 0 to 10. So the difference between these is 10. So 10 meters per second divided by 5. Step 4 is solve. We're going to solve the equation. 10 divided by 5. If you need a calculator, grab it. If not, we know that's 2. And because the acceleration is meters per second squared. And that's your first answer. Okay, let's do one more together. So again, if you need to, just jot down your 4 key steps. So bug it. We've got 5,000 meters per second to stationary, 2 seconds, and acceleration. It's about a rocket, but to be honest, I don't really care what it's about because all I'm bothered about is the answer to the question. So we see here, first of all, step 1 is bug. Step 2, the equation. Again, you should be doing this from memory. So time, straight away, easy, 2 seconds. So we know that t is 2. Change in velocity. It's gone from 5,000 to stationary. Now, stationary, that means they're stopped. That means they're not moving. But they're not moving, they've got no velocity. So therefore, they've gone from 5,000 to 0. So the change is 5,000. 5,000 in 2 seconds. That means divide it is 2,500. and the unit is meters per second squared. Again, two nice questions for everyone to be able to do by the end of the lesson, okay? The third question is, again, like you know, it's going to get a little bit tougher, and this time it's a bit longer. Let's read through it. Rob is in trouble with the police. He is travelling at A29, sees a police car and brakes from 50 to standstill. So again, bargain that question. Standstill, I now know that's 0. His deceleration was 10 meters per second squared. Deceleration is just slowing down. How long did it take him to brake? So we've done step 1, we've bugged it. Step 2, again, write your equation out. So I know that my equation looks like that. Step 3, substitute. Now we haven't got time, but we do know the acceleration was 10, so we can put A is 10. We can also see that we don't have time, as I said, to put there. We can see 50 to a standstill, so 50 to 0. So therefore, the change is going to be 50. So we now need to rearrange your equation to make t the subject. So again, draw a line that you do in maths, times both sides by t. So now it means you've got 10t equals 50. I'm going to divide now both sides by 10 to get t on its own. So that means t equals 50 divided by 10. So we need to do 50 divided by 10. That gives you an answer of 5. And because we're working with time, it must be 5 seconds. Okay, so that is my knowledge for you. You do have a slot sheet attached to show my homework. Now, if you have got it printed off, it looks like this. Okay, this sheet here, you've got 10 questions to answer. If you can't print it off, I'll just show it to you now, what it should be. So it's this sheet here. Okay, oh, next slide for you. Okay, the 10 questions you need to answer are there. Again, they start easy, they get hard as you go down. Actually, question 10 is a real tricky one, so that'll be a challenge for everyone, which I'm looking forward to get on with that. And again, we'll go through the answers next session. Again, next lesson we'll do some velocity time graphs. We'll take it to the last part of this topic. It's a short topic, but also very snappy. Remember, before then, do some material practice. We're going to set you a weekly recall test this week about these lessons. See you get on with that. So watch my homework, watch this space. And we have to complete the slot tasks, as you said. And then next video, we'll go through them. And don't forget to share the video. So I hope you have a lovely day, a lovely week, and I'll talk to you on the next video. Have a great time.